Folks, how can we already be on the last lesson of this chapter? It's crazy. So it's ending just like last chapter. We're going to have similar and congruent figures, and you're going to use our little roadmap to help us find the missing either like side length or volume. So it's really similar to when we had the ratio of our areas, but now we're going to have ratio of our volumes. So let's just recap a few things first. Similar solids have the exact same shape, but are different sizes, right? They're similar, but they're not congruent. So one's big, one's small, but they're the same shape. Okay? Whereas congruent solids have the exact same shape and are the same size. So their scale factor would be 1 to 1 because they are itself. It's the same as itself. It's 1 to 1. If I'm 5 feet tall, I'm going to be 5 feet tall if I'm congruent to myself, right? My scale factor is the exact same. It's 1 to 1. Okay, so if we review just a tish from last chapter, our scale factor here, I know this, you don't have this in your notes, but just kind of hang with me for a second here. We pick matching sides, right? So I'm going to have 4 to 8. And we know we reduce that to 1 to 2. Okay, the ratio of our area, so if I wanted to find the area of that little guy, 4 times 4 is 16. Ratio of this area, 8 times 8 is 64. If I reduce that, I'm going to get 1. 16 goes into 64 4 times. And you should be checking yourself, right? If I gave like the generic version of this, this would be like A to B. How do I get from the scale factor to the ratio of my areas? Well, we square it. So it'd be A squared to B squared. Let's just make sure we're true here. 1 squared does give me 1. 2 squared does give me 4, so far so good. Now our volumes. Okay, so we know the volume of a cube is base area times height, or 4 times 4 times 4 in this case, which is 64. And then same thing over there, 8 times 8 times 8 would give me 512. So now if we reduce that guy, we're going to get, let's see, 64 goes into 512 8 times. So if we want to do our little generic formula for this one, the ratio of your volumes is A cubed to B cubed. And let's just make sure that makes sense. If I come back all the way over here, if I cube 1, 1 cubed is 1. If I cube 2, 2 times 2 times 2, I do get 8. So I guess big takeaway, folks, on this whole thing is in your notes where it says scale factor, I would write A over B. Ratio of your areas or surface area would be A squared to B squared. And the ratio of your volumes is A cubed to B cubed. That's the big takeaway of me talking a ton. Okay, these first two, they're just asking us to determine if the solids are similar, congruent, or neither. If the solids are similar or congruent, state the scale factor. So we just have to see if our sides are proportional, okay? So that's easy enough. So let's just start with 4 here. What does 4 match my big one? 4 matches 6, and now we just reduce, and we get what, 2/3? Perfect. Now we'll match this guy, 8. 8 matches 12. 8 over 12, that also reduces to 2/3. So since we got the same simplified ratio, they are similar because our sides are proportional. And then our scale factor would be what we got when we reduced, so 2/3. That is our answer. Good job. Try another one. Okay, so we got a match here. So let's just pick any two sides that go together. Again, I'm the weirdo. I like to do like my small over small. So I know 1.5 has to correspond to the small side over here. So 2.5. 1.5 over 2.5. So I'm just going to get this one as a decimal. So if I divide out 1.5 divided by 2.5, I get 0.6. Okay, now I'm going to match my medium. So 1.7 over 3. 1.7 divided by 3 equals 0.56. Did we get the same thing here, folks? No, they're not equal, so these would be not similar. They're not the same. They're not similar. They're not proportional. Okay, this next part is going to kind of remind you of last chapter, or I hope it does. So it says 2 similar cones have radii of 9 inches and 12 inches. What is the ratio of the volume of the smaller cone to the volume of the larger cone? Okay, so if you're a picture person, oh goodness, you guys, here's my cone. Here's my other cone. The smaller one has a radius of 9. My bigger one has a radius of 12. Okay, so right now we have our scale factor because we know they're similar, and I have my 2 measurements. We know our scale factor, and we want to get to the ratio of our volumes. So in our generic terms, I'm at A to B, and we want to get to A cubed to B cubed. This problem's it's not too hard. It's kind of a nice one to start with. So let's start with our scale factor. So our scale factor would be 9 to 12. I'm going to reduce because I like smaller numbers. 3 goes into both of those, so 3 over 4. So this is my A to B, and if I want to get to A cubed to B cubed, we simply just cube them, you guys. Cubed, cubed. So 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. That's it. That's the ratio of our volumes. Done. Next one, we have 2 similar cylinders, and we're looking for the height. Okay, so now we're going to kind of work in reverse from what we just did. We know the volumes of both of our cylinders, and I'm trying to get to just our scale factor essentially. So our little, go like this a bit here. Okay, so our little roadmap here, we're going to start the ratio of our volumes, get to our scale factor, and then write a proportion to help us solve this, okay? So let's start with the ratio of our volumes. Do you guys see how we know both of them? So I can write 270 pi over 640 pi. And now this is where you really do want to reduce, you guys, okay? What's awesome is, look, my pi's are going to cancel. Both of those zeros will cancel. So now I have 27 over 64, okay? So our ratio of our volumes is 27 over 64. Now to get to my scale factor, right now I'm at A cubed to B cubed. And I want to get to A to B. So now I want to get to A to B. Well, how do you undo something cubed? You take the cubed root. Cubed root. So we need to figure out what number times itself 3 times gets me to 27. What do I want to do here? That would be 3. And the cubed root of 64 is 4. And now from here, we can simply write our proportion. So 3 over 4 equals, we're looking for the small one, so h has to go on top, over 10. And now we just cross multiply. So 30 equals 4h. Divide out, h equals 7.5 inches. I realize you might not know how to find the cubed root on your calculator, and I'm sorry I'm not doing this the other way where you can see my hands. If you are lost on how to find the cubed root, I will show you in class tomorrow or when I see you next, okay? So don't fret if you are lost on how to use your calculator. Okay, one more, kids. It says the softballs below are similar spheres. If the radius of the larger softball is 1.9, I'm going to do that right here. The larger one is a radius of 1.9 inches. find the radius of the smaller softball. So this is what we're looking for here. So folks, same exact problem we just had, but now just some different numbers. So again, we're gonna start the ratio of our volumes, get to our scale factor, write our proportion. Okay, we know both of our volumes. So 4.06 pi over 9.15 pi. Basically, the only thing that reduces on here is we can get rid of our pi's, and now we're just left with 4.06 over 9.15. Okay, so now we're just gonna take the cube root of those. Cubed root of those bad boys. The cubed root of 4.06 is about 1.59. And the cube root of 9.15 is 2.09. So that's my scale factor. And now from here we can write our proportion. 1.59 over 2.09 equals, we're looking for the small one, so R over 1.9. These are just kind of gross numbers, but it's all fine. We have calculators for a reason. Okay, so cross multiply. 2.09 R equals 3.021. Divide by R, divide by 2.09, and we should get about 1.44 inches. Okay, and we're done for notes for the whole chapter. So folks, thanks for playing, thanks for watching, and we will talk in class. Goodbye.